Greetings to all participants. Thank you for joining us, and we'll be starting shortly. Thank you. Sir, greetings. Thank you for joining, sir.
Thank you, Lupna. And as I can see, I welcome Dr. Gautam Chittopadhyay also on this virtual talk series. Welcome, sir.
Thank you very much. I'm really excited to be here.
Thank you, sir. And we're also looking forward to a very some fantastic lecture from you. And I think we have some 89 participants, and shortly we'll be joined by a few more.
Sure.
Yes, sir.
Good evening, Dr. Sudhana.
Good evening.
Hello, how are you?
Fine, fine.
But we are waiting for Director HCSIR to join. Then we'll start the session.
Okay.
Yes, good evening, Shazana sir.
Good evening.
Yes, sir. Sir, Sangwan sir will be joining shortly. He has some issues, but he's just trying to join. And then we can start, sir. Okay?
Sure, sure.
Yes, sir. Thank you for joining, sir. So in the meanwhile, Dr. Gautam, I would like to introduce you to Dr. H.K. Sadana. He is the Chief Scientist and Branch Counselor for our IEEE Student Branch. Yes,
Hello.
Dr. Sadana.
Hello, Dr. Gautam.
Hello, very nice to meet you, though not in person, but through this virtual world. But it's really, I'm so happy to meet you all, and you guys are doing so well. I'm so proud of all the students who are, putting together this kind of series. It's amazing.
Yeah, so are we. Our students are doing very well and able to connect everyone in this, global scenario, getting all kind of experts. And we are really happy to see NASA previously we have heard somebody again from NASA now. It's very nice that, people like you are sharing the Indian community and also globally in some cases the best of learning that you have had in India as well as in US. Great. Really nice for your gesture that you chose to be with us this evening.
So thank you. It's actually my honor, and I feel it very humbled by all these requests. So thank you so much.
Yeah, wonderful. And I think we'll be joined by the director ACSIR, and I believe you might have known this. ACSIR is more like a meta university, and it's largest. It has just come up to be a largest because CSIR, Council of Scientific and Industrial Research, has been there for more than 70 years now, before independence in India. But we recently, 2011 onwards, became, by the Act of Parliament, a kind of university status, in a way, institution of national importance, to be precise. And it is held at one place as a kind of academic office in Ghaziabad in UP near Delhi, and Professor Sangwan is the head of, in a way, director of that institution. So there is a connect of CSIR and ACSIR by way of naming, and otherwise you might have gained. And all CSIR laboratories, one fine day became the departments under ACSIR. And at that age, when we were already around 60 years old, in a way, in the sense of institution's age, that we started, well, we had been doing with other universities. So with this institutional tag with us, we could enroll students of our own with some humble beginning in 2011, and now we were already attracting lot of students for PhD. It's only 2011 we started owning under ACSR name that they are enrolled and registered for PhD. So that's on one hand we are 10-year-old, and on the other hand we are more than 70-year-old.
Yeah.
So that's how the institution tag is. Yeah.
Excellent. Mm-hmm.
So I hope you gathered this, and that brings us to have largest number of PhD scholars in the country. So that and because of laboratory and academic fusion, that brings us with some pros and cons, you can imagine, but largely we have been able to, ACSR has been able to make its name, and more so during this pandemic when they could approach people all over the globe and bring in virtually to us, to all of us.
Thank you.
Yeah. So, and we follow one coordinator. I think Professor Vinod Rar must be around. I couldn't see Rishabh. Is he already logged in?
Yes, sir. Yeah. Yes, sir. Sir is there.
Okay. So locally, every laboratory holds one scientist, designated as coordinator. So with a dual role of scientist as well as academic coordinator. So it's a very small team-based connectivity of, ACSR with laboratories, where laboratories conduct the research and academics together, and students and project fellows and a large team of postgraduate, scholars become the team or academic team, with faculty of scientists acting as academicians. So we are designated as chief scientist on one hand, some of us with other scientist designation, and professor, associate professor, and assistant professors on the other hand. So that is bit of brief. I thought this intervening time I would make use of, but I saw your CV very nicely put in on that website in NASA. So very nice. I think people must be eager to know more about you that Anupama will share officially some details about you.
Sure.
Everything, how is life recently? Any change? I like the title even, Are we alone?
Yeah.
I believe is the answer put in another way that we are not alone.
Let's see. You'll have to listen to my talk to find out.
Yeah, I think let's keep that fingers crossed on what you are trying to share. Yeah.
Okay.
Great to be. Yeah.
Yes, sir. Thank you so much, sir. So we can see Director CSIR, Professor Sangwan, has also joined. So we welcome you, sir. Thank you for accepting our invitation. So I believe without ado, I request for your permission to start the program.
Yeah, is it for me? Yeah.
Yes, sir.
Yeah.
So shall I start the program?
Yeah.
Yes,
Anupa,
thank you so much.
Anupa, I think we can have 2 words from Professor Sangwan. So probably
Yes,
we can start it. Because
Yes.
I welcome Professor Sangwan to this CSIR virtual CSIR IEEE virtual talk series. And we are indeed honored to have Dr. Doppler Method, the keynote speaker for today's workshop session. And I really thank and congratulate the CSIR IEEE students for having this event, and also we are honored Professor Sangwan that is under whose leadership. As Dr. Hadara, I think, put up that the institution has moved nicely over 2,000 students. So, Professor Sangwan.
Yeah. Dr. Gautam Chattopadhyay, good morning. And Dr. Sardana, Dr. Karar, and my dear ACSR students, and all of you from the country who was switched on for this lecture, a good evening. It's a great and a special day in this exercise of learning, and this exercise has been started by the students themselves. It's a matter of great pride for us, for ACSIR, and for the nation. And in this series, the first lecture, both the speaker and the subject that has been scheduled for today's lecture, both are enormously important in many ways, not only for the students and for the students of the discipline, but for everybody, every common man. Why I say that is, the human curiosity is enormous, and this curiosity is much higher when we look something beyond what we can see closely. When we look at the distance, we are curious. We are more curious when we look at the height, be it the height of a small mountain or be of a Mount Everest, and we are curious about it. And when we think about something like planets and stars, this is something that anything we know about is highly amusing, because as a not a person from a subject, but everybody thinks if we know something about something, we actually do not know how it looks like, how big is it, how small is it, and what is there in it. So that is what is the biggest question that is there. And it's a very attractive title when you say, "Are we alone?" It's a question that has many, many meanings. And in the scientific term, when we see ourselves as a part of the whole universe, and so far we believe that we may not be alone, but we do not know who our neighbors. And this is how is the quest, and this is how the curiosity. It's a great initiative taken up by students, particularly the students at CSIR CSIO. and led by Anupma. I'm sure it is a start, and it will accelerate. It will be impetuous to many other centers of ACSIR. As such, ACSIR is present all over the country. We have around 45 academic centers. Most of them are CSIR national laboratories, but there are laboratories other than CSIR also, from those from the Department of Science and Technology. And this is the way when the students, they connect to each other, they also know the fields beyond their own, and interdisciplinary thoughts, interdisciplinary research is a hallmark of ACSIR. And societal connectivity and societal intent with respect to needs of the society, needs of the humanity and planet. This is also, we have a small course, only somebody to think anything beyond subject and just have their thoughts on that. So with that, I will not be here for in between the lecture and between this time, so that our audience who are eager to listen to Dr. Gautam Chattopadhyay, thank you very much for sparing time. I know this is a very early morning for you, and we thank you for sparing this time. I'm sure this will be catalytic to many such lectures of this renowned scientist like you. Thank you.
Yes, thank you so much, sir, for your wishes and blessings. So I extend my warm welcome to all the participants and to our respected director, sir, that is ACSI Director, Professor Sangwan, our keynote speaker, Dr. Gautam, respected coordinator, Dr. Garar, and our IEEE branch counselor, Dr. Silvana, and to the Director IIP who has joined us, and also other ACSI family and IEEE family. So at the outset, I would like to extend my warm welcome to the speaker and briefly introducing our speaker to our audience. So Dr. Gautam is a senior scientist at NASA's Jet Propulsion Laboratory at California Institute of Technology, and he's also Institute of Technology, US. He received the PhD degree in electrical engineering from the California Institute of Technology in 2000. He is also the fellow of IEEE USA and the fellow of IEEE India and an IEEE distinguished lecturer. His research interests include microwave, millimeter wave, and terahertz receiver systems and radars, and development of space instruments for the search of life beyond Earth. He has more than 350 publications in international journals and conferences, and he holds more than 15 patents. He also received more than 35 NASA Technical Achievement and New Technical Invention Awards. He received the IEEE Region 6 Engineer of the Year Award in 2018, Distinguished Alumni Award from the Institute of Engineering, Science and Technology, India in 2017. He's also the recipient of the Best Journal Paper Award in 2013 by IEEE Transactions on Terahertz Science and Technology. So with this brief introduction, I welcome you, sir, for your talk. Yes, sir. Over to Dr. Gautam.
Thank you so much, Anupama, for the introduction. And I'm very glad that I am here. I'm able to talk to you all. And I want to thank, our Professor Sangwan, the director, and all the other participants here. And special thanks to Anupama, because she contacted me over LinkedIn and asked me to join in. And I am always ready to talk to students, because we believe that students are our future, and if we can somehow inspire them and tell them how to carry out scientific research, how to have an open mind about research and science, that bodes really well for us. So I'll start sharing my screen, and let's start. So I hope you all can see my screen now. Okay, so what we are going to talk to you about today is, are we alone? And what NASA has been doing in search of these questions, that, are we alone in this universe? Is there any life outside our Earth? So that is a big question that actually that bothers all the human beings. We are always concerned about that, and if we and I will try to tell you where we stand in that quest, And also, that a lot of things that you are reading and you see on the internet, you should be very careful about those. So let's get going. So before I start, I want to acknowledge my teammates. You can see that in my team we have about 24 people, and if you pay close look on them, you will find that they're from all over the world. So that is one of the things that makes NASA great, that we have huge amount of diversity of talents. People come from all over the world. They're the best and the brightest. So I am so fortunate to have these colleagues who come here from places like Spain, in Germany, in France, in Nepal. I'm from India. So, that's what, this amalgamation of all this talent, and that is one of the main reasons that NASA has been successful, because when we have people from all different parts of the world, and we have diversity in gender, we have diversity in kind of racial diversity, that's when we do well. So in this era, that that a lot of things are going on. So we are very cognizant of that at NASA, and we have been really trying to address those inequalities. So I'm very glad that I'm part of this great organization. So before I start my talk, I also want to say a little bit about me, how I came here. So my journey from a small village outskirts of Kolkata, India, here. So I grew up in a small town. It's not a town, it's a village called Novogram. That is, about 15-20 kilometers from Kolkata. But it was a village when I was growing up. And I also grew up in a very, family, with not very well-to-do of families. Kind of, we had a lot of economic hardships. But my parents always insist. We are 6 brothers and sisters. I have 4 sisters and a brother. And my parents always insisted that education is the key for us to get out of poverty, and that is true for many of us even today, across India and across the globe. That if you have a good education, then you can make a good future for yourself, and that's what we all did. We studied hard. Then I went to Bengal Engineering College under Calcutta University. It is now known as Indian Institute of Engineering, Science and Technology. And then I joined TIFR, Tata Institute of Fundamental Research, that is in Mumbai, but I was in the radio astronomy group. We built the giant meter-wave radio telescope in India, and I met people like Professor Govind Swarup and Professor Nalikar, Jayant Nalikar, very famous astrophysicists of India. Unfortunately, Professor Govind Swarup passed away, 3 days ago at the age of 91. I learned so much from those people. And then I came to US to do my higher studies. I did my master's from University of Virginia, then came to California Institute of Technology to my PhD. Caltech, California Institute of Technology, is a very small university, only 2,000 students, but it has a big name. 42 Nobel laureates came out from Caltech. So sometimes I feel that I'm dreaming, because when I walk by, the person that is next to me is a Nobel laureate. So it's kind of a very different kind of feeling. And also when I was doing my PhD, though my department was in electrical engineering, but my PhD thesis advisor was in physics. And every winter, Professor Stephen Hawking used to come, and he used to, sit 2 doors from my office. And so I used to talk to him. And so that has been, is amazing feeling that, talking to a legend like Stephen Hawking, and all the physics professors from Caltech used to come, and some of them went on to win Nobel Prize, like Kip Thorne, who got Nobel Prize in 2017 for the discovery of the gravitational waves. So, and then one day when I was finishing up my PhD, I got a call from NASA, and they said that they want to offer me a job. And luckily at the time we didn't have any video phone. Otherwise, they would have seen that I'm jumping up and down. So I was so happy that I could join NASA. So then I have, it's about 20 years now. I'm working, you can see my background is the entrance of my lab, NASA Jet Propulsion Laboratory. And I have, every moment of it, I'm enjoying it because I still feel that I'm a kid in a toy store. It never happens that on Monday morning, I never feel that, oh, I have to go to work again because I'm so excited to go to work. So I am really, sometimes people say, that you should work at a place where your passion lies. And I am one of those lucky people that I am actually living my passion and living my dream through the work that I'm doing. So that is a little bit of background. So let's go to the talk. So NASA has different centers all across the United States. So Washington, D.C., we have the headquarters, and we are here in Jet Propulsion Laboratory in Pasadena, California. That is on the West Coast. This is the largest robotic labs for NASA, and we do all robotic missions like mission to Mars and all. You all know that Mars rover Perseverance, it was launched on July 30th. Now it is on its way to Mars. We'll arrive there in February 2021. We actually built it in our lab here, so we do a lot of stuff there. So let's start. So this is the history of our universe. We believe that the universe started with the Big Bang. This is the Big Bang theory. This is not the Big Bang theory that you watch on TV. This is a real Big Bang theory. The age of the universe is about 13.85 billion years. We know that now, kind of pretty well. And however, we can actually go back in time using electromagnetics, and you can see, kind of understand what happened at the beginning of the universe. And it turns out that the first light of the universe came out about 280,000 years after the Big Bang happened, and that is called cosmic microwave background. And then from there, the universe expanded, very rapidly, and then all these, stars and galaxies started forming, and the planets started forming, and here we are. So one of the questions that, the premise of this talk, that are we alone? People ask me this question, right? Are we alone in this universe? Is there life anywhere else? So let's set the stage clear first that we have not found life anywhere. No form of life, not even a single cell life anywhere outside our planet Earth. We have not found yet. So that is whatever you read about aliens and everything. I know a lot of questions will come about aliens, but we have not found any aliens. We have not found any form of life anywhere yet. But is there probability of finding life anywhere? That is the question. And my answer to that is I believe that there could be life outside our Earth. How do I say that? Why do I say that? The reason is if you do a back of the envelope calculation. So if you look in the sky, you will see all these stars, right? And there are billions and billions of stars. In our own galaxy, the Milky Way galaxy, we have about 100 billion stars. 100 billion is a very large number, 10 to the power 11. So 11 zeros after 1. So that is a big number. And in our universe, we have about 100 billion galaxies. So if you do your math, you realize that we have 10 to the power 22 to 10 to the power 22 stars order of magnitude. So that is a huge number. And we are finding increasingly that many of these stars has planets. And not only one, they have multiple planets like our own sun. So what is the probability that in all those trillions and trillions of stars and those trillions and trillions of planets, there is one planet where the conditions are such that life can exist? The probability has to be finite, is non-zero. That's what we are actually searching for. And what we are searching for is the life that we know of, the kind of life that we know, our kind of life, that is carbon-based life, which needs oxygen, which needs water. And people ask me that maybe, there could be life of other kinds. Absolutely. But how do you search for that? You cannot really search for something that you don't know about. You can search for something that you know about actively. So there is actually, I come from Bengal, and there is a poet you all know, Rabindranath Tagore. He was the first Nobel laureate from Asia in literature. He wrote a beautiful song about this science aspect about life and universe, And there is one line, and I'll say that in Bengali first and then translate. It says that Janar Majhe Ojanare Korechi Sandhan. It means that we are searching about the unknown through what we know. And that is very apt because we always search about unknown through our own knowledge, because that's how we can actively look for. Maybe we'll stumble upon other forms of life, but we can actively search for that. And you all know that NASA has been going back to Mars, because one of the prime driver of whatever we do in NASA, we do science. Science actually drives all our technology development. And one of the main question that NASA is trying to answer to this, that is there life anywhere else? So we keep going back to Mars. Many of you know the reason is that actually in this early history, Mars resembles very much like our own planet Earth. So that's why we have a lot more to learn about how life forms, or does life exist on Mars today, or did it exist at any point of time? That's why we keep going back to Mars. And you all, if I show this picture, India monsoon is going on right now, so a lot of roads look like this. So if I tell you that this picture is from one of those roads in India, you might say, oh yeah, no, this is actually from Mars. And if you look carefully, what you will see that this kind of terrain we get only when there is a flowing water. If we look at the stones and everything, so which means that at one point of time on Mars there had been flowing water. But when you go to Mars today, we don't see. There is very little bit of water under the ground. However, there is no flowing water. The question is, what happened? Where did that water go? Can it happen to our own planet Earth? What can we do to prevent those kind of situations? So these are very, very important questions for mankind. And we are actually trying to understand by going there through scientific explorations. So with the lot of rovers that we have developed at NASA, you can see in 1996 we had Pathfinder and two rovers we built in Spirit and Opportunity 2003. Then Curiosity was launched 2011, and the latest and greatest one March 2020, that is Perseverance rover, that is on its way to Mars now. So you can see that the sizes of the rovers have increased, as increased the complexity and the challenges, that how we can actually build them. How landing on Mars is extremely challenging. You know that many of the countries, even with their best effort, has not been really successful in landing on Mars, because not that they are not good enough. They are extremely good, like ISRO and others, but it is extremely challenging to land something on Mars. And so let's hope that we land our Perseverance rover successfully in February. So this is how the Perseverance rover looks like. There are a lot of instruments on that. Going there and landing is one kind of challenge. And the second part that I am involved in is actually building the instruments that does scientific exploration. We have a lot of different scientific exploration. We have Charlotte, we have Pixel. So different kinds of instruments. We have a lot of cameras to do scientific cameras as well as engineering cameras. Engineering cameras help us to land and take pictures and send back to Earth. The scientific cameras will do optical experiments. So this is the picture from our lab of the Perseverance rover. It got ready. It was just ready to be shipped to Florida for launch. And you all know that it got launched on 30th of July 2020. So this picture was taken in our lab. So one picture I want to show you to this one. This picture was taken from the surface of Mars by Curiosity rover. What you see is, if you expanded section here, is Earth and Moon. Why I'm showing this is that sometimes we work in our lab, build very small things and do experiment with that. But whatever we do is very important. What the students, all of you, in a small way that you are doing, always keep the big picture in mind, because what we individually do in a small thing, that is very, very important. Because look at this, we actually work in the lab, build a small part of it, that went into a rover, that rover went to another planet, And this is the first time our planet Earth was pictured from the surface of another planet. That it gives us huge, excitement and boost. And on top of that, sometimes as human beings and mostly young people, you all think that we are great, we are the best. We have a lot of ego, so that takes over sometimes. So I believe that when you see, that kind of ego comes over to you, next time think about this picture, because in the big scheme of things, we are just a dot in the sky. And hopefully, this image will ground you. And you all know for electrical engineers, grounding is very, very important. So how about the exoplanets? As I said, the exoplanets are planets that we are looking for, that is around other stars, not our own sun. So we have been doing that. We have actually found more than 4,000 exoplanets in our universe. And we mostly looked at our own galaxy. And you will find that we are finding all different kinds of planets. We are finding big gas giants like Jupiter. We are also finding like rocky planets like our own Earth. So we are actively looking for planets which we call, are in the habitable zone. What do I mean by that? Because if they have to have life, they have to be habitable. They have to have the surface temperature such that water can exist in liquid form on the surface. That will enable them to have life. So that's what we are looking for. We are looking for planets in the habitable zone. It's also called the Goldilocks zone. And we have found quite a few of the planets which are in the habitable zone. But unfortunately, they are kind of far off, like they're 4 light years away. When I say 4 light years, we don't get the sense of the distance. It will take about millions of years for us to reach there with the current day technology, if something is that far, which means that we won't be able to go anytime soon unless and until we develop some new kind of technologies. However, we can actually learn a lot of things from sitting here, or either on the planet Earth or going to space, that we can do. And we have been, so how do we find these planets? That is one of the questions, right? Okay, before I go there, we can say that we have trillions of planets. How come we found only 4,000 of them? The reason is, so far we have looked at only a very small areas of our own galaxy. We have not seen much yet because we don't have the technology. We have started developing this kind of technology, which means, we have just started scratching the surface of this big question. So with future, we have new technology, then we'll be able to do more and more on that. So NASA is really investing in that. So we have planned missions for future. We will be able to look for more number of stars to see how many planets are there, what kind of situation in those planets. So how do we actually find out these planets? How do you do is it's very challenging, to be honest. You need extremely sensitive detectors to do that. So if the planet is going around the star in the way that's shown on the left top of the screen in our line of sight, then we'll be able to see the planet. However, if we see the planet going around the way it is going on the right side of the screen, then we can detect. What we do is somehow we isolate the star that we are looking at. So, and then we try to measure the total amount of light that is coming from the star. These stars are far, far away. They're very faint, but we try to detect the total amount of light. And then when a planet goes in front of that star, the amount of light dims ever so slightly. By detecting that dimming of the light, we'll be able to tell that there was a planet that went in front of that star. And then we can learn a lot of things about how much time it took to traverse, and then what is the size, and also with the gravitational experiments, we'll be able to tell that is it a rocky planet, is it a gaseous planet, what is the density, so does it have an atmosphere? So a lot of things we can actually learn through our scientific experiments, and that's what we are doing. There's another way to detect the stars is called Doppler method. What it does is when the planet goes around the star, the frequency that it shifts, you all know the Doppler. So either it shifts left or right depending on whether the planet is approaching the star or receding from the star. By measuring the change in frequency, Doppler frequency, we'll be able to tell that there is a planet. So, okay, so about finding the water and oxygen in those planets and in this universe. So, as I mentioned, one of the important molecule that we'll have to look for is water. Search for water when you are looking for life. So, is there enough water out there? Answer is yes. And not only that, we are finding that from sun-like young stars, water molecules are coming out at extremely high speed, 200,000 kilometers per hour. If you fire a bullet from a AK-47 rifle, the speed of the bullet is 2,500 kilometers per hour. So these water molecules are coming 80 times faster than a bullet. And if something travels that fast, it tries to destroy, but conditions are such that it finds a way to recombine and create huge amount of water. How much? 100 million times the total amount of water in the Amazon River is being created in one of these stars per second, which means that this universe is flooded in water. So if there is so much of water, that means some of these planets will have that water. And then we are actually looking for that. If there's water, then the possibility of life increases. And one of the things that we are also doing, I'm building an instrument right now to answer this question that when Earth was formed, there was no water. Scientists believe the Earth's water may have come from the comets. These comets might have brought water to Earth. So if I tell you that, we have all scientific mind because we ask questions. Whenever we hear something, we ask this question. You will ask me, and that you'll be right. So how do you prove that actually comets brought water to Earth? So we'll have to actually have a scientific explanation for that. So how we do go about knowing that is this, that it turns out that water is a different color, in the sense the water that we drink every single day is one kind of water, that is H216O. Oxygen has different isotopes. The most stable isotope of oxygen is 16 isotope. So that when it forms water with that H216O, it has some kind of abundance, but there are other kinds of water. We have H217O, H218O, and HDO. That is one hydrogen, one deuterium, and one oxygen forms water as well. And we all know heavy water, D2O as well, we know. So there's all these different kinds of water. It turns out that the ratio of the abundances of these different kinds of water, if you measure on planet Earth and if you measure on those comets, in some cases they are exactly the same. If the ratios are same, the source has to be the same. So that's how we can do high resolution spectroscopy instrument, go to a comet, measure their water abundance ratios and D over H ratio, what you call that. What is the amount of deuterium and hydrogen in those water? That will tell us if the water came from comets or not. I'll talk a little bit about the instrument part of that toward the later of this talk, that I'm building a very small shoebox-sized satellite to go to a comet and do this kind of experiments. That is very, very exciting. And also, if you look at, I'm talking about finding life in, far-off planets. But can there be life in our own solar system? Answer is there is possibility. We don't know yet. Like, look at this. This is a Saturn's moon Enceladus. What you see is the water is gushing out from here. If you actually expand it, you see this was detected using an instrument called Hi-Fi instrument, Herschel Space Observatory, and I actually built receivers for that instrument that made this discovery. And we are finding that water is coming up, which means that this is a very cold planetary body. So all ice. So if the water is coming out, it has to have a mantle, that is, have some source of energy, right? So in that case, that if there is a source of energy that is coming out, then so water coming out, there is a source of energy. Is there life? Is there organic? What else is coming out from there? Is it organic material? We don't know. So we are actually trying to build some instruments, and there is an idea of NASA to go to have a mission to Enceladus to find out if there is life in this Enceladus. So another thing that we can do also is Okay, let me see why I'm not able to. Okay, so another planetary body there where there could be life is on Europa. Europa is a moon of Jupiter, and it is a very cold planetary. Like our sun, our Earth has only one moon, but Jupiter has multiple moons, and it turns out it is a very cold body covered with ice. However, there is a liquid water ocean underneath. That's what we believe. And we believe that the thickness of the ice shell that is separating the water from the surface is about 15 to 20 kilometers, 15 to 100 kilometers in depth. And then there is a liquid water ocean, which means there is a source of energy that is keeping the water in the liquid form. So is there life in this liquid ocean? That is a big question, right? So if I come to you, if NASA comes to you, to the students, and say, okay, we are planning a mission to go to Europa, is a Jupiter's moon, and there is a water ocean underneath 15 to 100 kilometer thick ice, what kind of instrument you are going to build to find out there is life there? So this is the question we deal with all the time, right? As a scientist, my role is actually think about what kind of measurements we can do, what kind of instruments we can build to answer these questions, right? So the obvious answer is that we should send a drill a hole, lower a bucket, and see if there's any fish. Okay, I'm a Bengali, I like fish. But if you think about it, it takes 7 years to go to Europa. On top of that, total amount of mass and power that is available for this mission is really limited. About 300 to 400 total amount of power, watts of power we have available. So that means 3 to 4 light bulbs. What kind of drill you can have to drill a hole of 50 to 100 kilometers through ice with 300 to 3 light bulb equivalent of power? Cannot do that, right? So, but there's another way. We are finding that a lot of cracks in this ice, and the materials come all the way to the top. And then when it comes on the top, it freezes because it's so cold. But Europa is close to Jupiter, which means that Jupiter has a very high magnetic field, which means very high radiation. So what radiation does is sputters the material in the atmosphere. And we are trying to build instruments to look into those things, what is coming out in the atmosphere. Is there any organic materials? Organic materials does not necessarily mean life. However, it is a precursor to life. So we are actually thinking of, there is a mission NASA is planning to go there and do all these experiments to find out what else is coming up. Is there any possibility of life in the Jupiter's in the world? So this is very, very exciting thing. So the question is that what kind of instrument we can build to address this? Those are the science questions that we are trying to answer. What next comes the technology and instruments. So we have to make things really small. You have to innovate. You have to make things small. You have to make things low power so that we can send things out in outer space. So we are very good in making things small now. You all know that when the first IC that was developed in 1960 had 3 to 4 transistors, and if you look at today, we are building ICs which has billions of transistors, and majority of them actually work if you think about it. But making the chips is not enough because you have to put it together in a system. That's why when you are studying in your college, you are doing PhD, you are doing undergraduate studies, you should always think about it's just not one component. You have to think how to build an entire instrument. If you look at this was a 1970s. This is a radio transmitter. How big it is! One human being is standing here, and you know what this one is on the right top screen of yours? That is iPhone 5. Entire circuit of iPhone 5. Have you all opened your smartphone? If you have not, you should. I opened my wife's iPhone. Okay, it was water damage. That's why. So if you open it, you'll you'll be amazed to see that what kind of engineering has gone in. That not only there are chips, but all this packaging, all these connectors, all these interconnects. So this is beautifully done. It's a piece of art. We are also doing that. We do that for space systems as well. We are using all these very high performance chips and we are trying to put it together. But again, they have to work in space. If you take an iPhone in space, it's not going to work because, radiation environment and all. So we'll have to make sure that they work, they're safe, and that's where the challenge lies. But we are doing it. And we're also building, as I was saying, a lot of small satellites. These are of shoebox-sized satellites. They are called CubeSat. We are actually building a lot of them, and already many of them are, are in the space, and few of them are being planned again. And recently, we had a CubeSat that we launched called Marco. That was the first CubeSat that went to Mars. It's called Mars CubeSat 1. What it is that when we have a rover or an instrument going, the spacecraft going to Mars surface, for about 7 to 8 minutes, we do not have a direct link to Earth. So we don't know whether it actually touched down, what is the health of our spacecraft. So what we did for InSight mission, that we actually have a very really shoebox size. This is a 30 centimeter by 20 centimeter by 10 centimeter satellite. And what it had, that when it launched, the spacecraft was going to the surface, it released these small satellites, and it had two communication systems. One was, talking the spacecraft in the UHF, and another one in the X band, it was talking directly to the Earth. So the data was coming from the InSight spacecraft going to this Marco, and Marco was sending the data back. So we had kind of a always update what is going on. So we are building this kind of instruments. Another thing that we developed in a small CubeSat is called RainCube. RainCube is a radar on a shoebox-sized satellite, but it has a very large antenna, 50 centimeter antenna. So how do you put a big, large antenna? Because we need large antennas to do all these, scientific experiments. How do you fit in a very small space a large antenna? That is one of the challenges. But that is what actually pushes us to come up with new innovation. So we came up with this antenna. This is a 30 gigahertz antenna, but 50 centimeter in diameter. But it has to fit in 10 centimeter by 10 centimeter volume. Think about it. It's really, really challenging. But we solved that problem. I'll show you a video showing, how it is deployed. This is a spring-loaded. Oh, okay, sorry. So if you look at this here, we release the pin, the spring, and then it just deploys. This mesh antenna, and then there's another structure. This is called subreflector that also deploys. And only thing is that once it deploys, you cannot put it back. But it deploys very well. It's actually working very, very well. So that's what we'll have to do. We have to build new kind of instruments, new kind of antennas. So we are developing something called metasurface antennas. These are flat antennas with all metal structures. These are very innovative structures. We are doing it with 3D metal printing. We all know that 3D printing has taken off quite a lot. And even at a university level, students can use those. So you will be able to really use some of these techniques to deploy them, to develop new antenna technology. So the lot of things to be done, and that's why I'm looking at all the students who are listening in. For you all to come up with new ideas and come to us, we'll be very happy to actually see that if your idea works or not. So I'm building something with this kind of antenna. You can see, again, this is shoebox size. This is 10 centimeter by 20 centimeter by 30 centimeter, entire spacecraft, but it has to have very low power because this small spacecraft cannot have a lot of power. So this is the instrument that I'm building. I told you that we are planning to go to a comet. Idea is to water hunting advanced terahertz spectrometer on ultra small platform. That is the acronym I came up with. I call it What's Up because we are trying to answer this question: What's up with water? Did water actually came from comets? So we have this is just a little bit of technical detail and how it looks like this instrument. If anyone has question, I can talk more about it. But there's a lot of innovation has to go in. And that is the challenge, and that is the excitement as well, that we are building always new things, and we are using a lot of CMOS, that iPhone technology or smartphone technology, what you call SoCs, their system on a chip. So a chip has entire system on it. So we are developing synthesizers, spectrometers, and all kinds on a chip, and then put all of them together in an instrument. This is how the system looks like now. You can see it is really small. It's a very highly powerful instrument, but that we are able to put everything together in a very small package. This the sensitivity of these instruments are amazing. That we can actually detect water in parts per trillion level. So it is so sensitive, but again, they're really small. You can see this is a US penny, and the size, total mass of this entire instrument is less than 2 kilograms, and it draws only 5 watts of power. 5 watts is actually your night bulb takes about 2 watts, 1 to 2 watts. So think about it. So this is doing all kinds of stuff with this so low power. So that is the key. And then I will end with something else, that is Mars helicopter. You all know that the rover that is going to Mars, the Perseverance rover, has a helicopter. It's called Ingenuity helicopter. So what is the excitement about this helicopter? What is the big deal, you might ask, about this helicopter? The reason is that helicopter on Earth, when it flies, that is you all know that it has rotating blades. They rotate about 400 to 600 RPM, revolution per minute. But Mars atmosphere is much lighter compared to Earth's atmosphere. As a result, that we need the rotation to about 2,600 to 3,000 RPM. So that is a huge difference. And what is the idea? What the helicopter is going to do on Mars? The reason is, that it takes light at the speed of light, and communication that we have, 7 minutes to reach Mars. So when we send some instruction to Mars, what the rover is going to go, we upload everything beforehand, and then the rover goes and does experiments. But with this helicopter, it will be mounted on the rover, and it will take off from there, and then it has a lot of sensors, cameras. It will go around and take all these signals in, and then send it back to the rover, and then rover can decide where is some interesting things are going on. So it is, this is we are doing a demo. This is for the first time. It has, it weighs only 1.4 kilogram. It cannot weigh much because then we need more power. It has about 220 watts of solar cell power on this helicopter, but it can recharge again. And then, it's ready. Hopefully, this is how it looks like just before it was integrated on the rover, our Perseverance rover. This is how the Ingenuity Mars helicopter looks like, and hopefully it will work well. We'll find out, because it's going to land in February 2021, and then we should all check how it is doing. So I hope it works great. So with that, I'll end. Thank you so much for listening in, and if you have any questions, I'll be very happy to answer your questions. So with that, I'll stop sharing. Thank you very much.
Thank you so much. Now it's open for questions. So firstly, I would like to ask Dignity if they have any questions. So first we can take from the Dignity.
So, any questions? Maybe questions can come from the chat box also.
Can I ask a question?
Yeah, any question? Please go ahead. Dr. Gautam Chattopadhyay is listening. Please go ahead.
So if you have any questions, because I cannot really go through the questions and ask. And Anupama, I am not able to hear you. Your voice was breaking off.
Am I audible?
Okay.
Yeah.
Hello, participants. If you have any questions, please post it to the chat box, or you are free to ask us directly. We will take your questions from the chat box. And there's one question from Mr. Prithvi Raj. The recent news about finding the alien spaceship by US Navy. Is it true?
No, that is not. US actually has not found alien. Actually, we have not found any of those. So a lot of things that you read in the news is not really true because a lot of fake news is going around. So try to whenever you hear. I want to actually really request all of you that is for us because you are bringing up this question. You'll find that some group of people they create news that are false and then they spread and we become the vehicle of spreading that news because it comes to WhatsApp and before checking, I know all of us has this tendency of forwarding to others. Next time, please, before you forward anything, do a little bit of your own research. That is it really true? Because if it is not, they depend on you to forward this and then spread this false information. So you are all are citizen scientists. So your role is to make sure that whenever you see something, ask this question. I always do that, and you can get the answer. This internet, spreads a lot of bad information. At the same time, internet also has all this good information as well. You can check and find out is it true or not. And if you cannot find out whether it's true or not, don't forward it. That's it. It's like COVID-19. You know how COVID-19 we can stop is by wearing mask, and we are the mask for this about this misinformation. So we should stop spreading misinformation. We have to be the mask in the analogy in the COVID world. So I wanted to say this out. Thank you very much.
Next question we can take from David. That water in the slide you have mentioned that water is coming out. Does this mean Enceladus has poor gravity?
The reason is the Enceladus is a small planetary body that has its own gravity, of course, because it has a mass. However, it is close to Saturn. So Saturn is much larger object. As a result, it goes around Saturn. So Saturn's gravity is much more. Like the way something comes. If you look at the moon goes around our planet Earth because of the gravitational pull and push between moon and the Earth gravity system. So same way, Enceladus and Saturn has this the gravity system. That's why you'll see that suppose there is a geyser here on planet Earth, you'll see the water will come out, right? Will sprout out the same way. That water is coming out from Enceladus.
Okay. Next question.
Hello.
From
Hello.
Yes, please.
Can I ask a question?
Yeah, please go ahead.
Yeah. Hello, sir. Thank you for this session. I would like to ask one thing that I personally work on 3D printing of metals. And I want to know that suppose I am going to design some material that are for the application of extraterrestrial, such as spaceships or something like that. How should I mimic the conditions of the extraterrestrial planets? Such as if I target for the Europa, that is it is covered with ice and all. What should be the temperature and other physical parameters? How should I mimic it? Where should I get this kind of information and all?
Actually, thank you very much. I think if I got your name, you are Avradeep Das. So
yes,
thank you for asking this question. That is what we do. When we build anything, we'll have to mimic what kind of condition that is going to go through. It's not only that when it reaches there, also in the path of reaching, it experiences heat, cold, as well as radiation. So for when we build something, what we call the environmental test. So in our lab, we do a lot of environmental tests, and these environmental tests are temperature cycling. So we know all the. If you go to NASA website, nasa.gov, we find the conditions, the temperature, and all other details. Like if you are going to go to Jupiter or Europa, it is a high radiation environment. So you'll have to test under radiation conditions. We actually test it in megarad of radiation environment, of doses. So there's a lot of challenges to do this kind of test. but we have facilities. In India, ISRO has these facilities to, as it's called, the environmental chambers, that you can actually heat it up, you can cool it down, you can, vibration test you need to do. You also need the radiation test, so lifetime testing. So why it costs so much money for space missions is because all these tests that we have to do. And that's what we do. And you can find this information available on NASA website. I'm sure it is available at ISRO websites as well. Next question.
Yeah. So I continue the question from the chat box. There is a question from Mr. Arya. Can you shed some light on the student exchange programs run by NASA for international students?
That's a good question. So first of all, before I talk about NASA, you should also look into ISRO. Because many of you are in India. ISRO is an amazing organization. They are doing a lot of space missions and all. You should look at what kind of internship opportunities you have in ISRO, so that you can learn from there. It's an amazing place. So in terms of NASA, yes, we have a lot of internship programs. And if you go to nasa.gov website, you will find that we also take international students as well. However, we have a limited capability of taking international students. So under NASA guidelines, we can take only 100 international students for internships and everything per year, not more than 100. So that is set up by the government of the United States. So if you have to apply early, you'll have to be, it is very competitive, of course. But one of the way to come to NASA to work, to learn, as well as even to get a job is through something called postdoctoral program. If you are doing your PhD, and then after you finish your PhD, you can actually go to, there's a website called NPP, NASA Postdoctoral Program. If you go there, you will find that it actually has a lot of information. So you can come, we take people from all over the globe, not only from US. So that is open to everyone. You go there and apply. Again, it's very competitive, but however, you can have, a lot of people, they come here. So that is the easiest way. And then once you come here, then if you do well, there is always the opportunity to actually get absorbed at NASA. And another thing that you can do is do higher study in the United States, and like master's or PhD, then you can apply for a job. So these are the two best pathway to come and work at NASA.
Okay. Next question from Ms. Indu. What is the concept of digital twin used by NASA in 2002, and how it may affect the future research?
So I missed the question. How is the digital, what did you say, digital?
A concept of digital twin that is used by NASA in 2002.
Oh yes, of course. We are using it. Since then, actually, it has become much more advanced. From 2000 to 18 years ago. So we are. It is a very, very important area of research that is going on. The answer, one word answer is it has been great, and we are continuing to use those and improve those.
Okay. So how it can affect the future research?
Of course, if you are working in that area, you should pay attention. What are the thing is that when you are doing a research, you'll have to do fundamental contributions. Like you have to find out the one aspect of it, the usefulness of that. So you already know this is very useful. The other side is that how you can improve the technology that you have developed. So that's what you should look at. It's actually, it will impact the future research in a big way. And we are really hopeful that it will even move forward with contributions from all of you.
So next question is from Partha. Does a Goldilocks zone shift in the solar system?
I missed the word.
Goldilocks zone.
Goldilocks zone. Yeah, our solar system, Goldilocks zone is our Earth. You can see that Earth sits in the Goldilocks zone. Even Mars actually sits in the Goldilocks zone, because Mars can have water. There was water on Mars at one point of time in the liquid form, as I showed you in that picture. which means that, Earth, Mars, they, sit on the Goldilocks zone. So Goldilocks zone are the habitable zone where in any planet where the surface temperature is such that water can exist in the liquid form on the surface of it. So yes, so in that way, our Earth and the Mars both are in the Goldilocks zone, but we are trying to find out other planets which are in that Goldilocks zone, which can harbor life.
Okay. So next question is from Akash. So he is asking that about a rover sample collection, how it analyzes the sample and send data back to Earth.
Yes. So what we do, the rover itself, when you have an instrument, what it does, it actually collects sample and then it analyzes it. I'll give an example. What we have a drill. So it on the rover, Mars rover, and it actually goes through and finds some stones. It drills that stone, take the material out, and it has a laser spectrometer. It actually sinters that using a laser, and when the gas comes out, it does some kind of spectroscopy. And it also has a mass spectrometer. It takes materials and sends it through the mass spectrometer and then analyzes it, stores the data. And when there is a direct link to Earth or there is other satellites going around Mars called MRO, Mars Reconnaissance Orbiter, it actually sends data to Reconnaissance Orbiter, which has a much larger antenna, so that it can send that data back to Earth. So that's how we operate.
Okay, next question is from David again. So what is the science behind the Bermuda Triangle and where are all those lost planes and ships?
To be honest with you, Bermuda Triangle is still, but people think that there is a sense of, some kind of magnetic field and that's why it crashed. I have no idea where those things are, but, if you spend enough time and effort, I'm sure you'll be able to find those things. But why those crashes? There is a lot of, if you go to internet, actually you can find there is a legitimate, is not fake, legitimate explanation, legitimate, idea of, what could have happened in that. So there is some atmospheric phenomena, some, Earth magnetic phenomena that might be the reason for some of these disappearance of or crashing of those planes.
So next question is from Himanshu. Are we ready to land on Moon again?
The answer is yes. NASA is planning a program called Artemis. We are supposed to be ready by 2024. The idea for this Moon program now is slightly different than our old Apollo programs. Apollo programs, what we had, that we were sending a mission directly to land on Moon, right? But through the Artemis program, it is like ISS, International Space Station. So we call it Gateway to Moon. So you create a International Space Station kind of, station that is going around Moon, and then you go there, and from there you go and land on the Moon. So that is the idea for this Artemis program. And again, it costs so much money. So one of the constraints we have is about resources. That where do you spend the amount available money? Do you spend going back to Moon, or do you spend exploring in other things? There's so many things to do. So that's what we'll have to be judicious about.
Okay. Next question is from Mr. Shekhar. Is the universe conscious?
I don't know what do you mean by conscious, because how and universe in a way an inanimate object. So consciousness and all that is, we believe, are living objects has these. So I do not know what that question means, that whether the universe is conscious or not, but we'll have to be conscious about all this.
Yeah. So next question is asked by number of people. So is there any developments by NASA on ISRO's Chandrayaan? Any new development?
So that ISRO is doing it. So of course, not from the NASA perspective, but from ISRO perspective, yes, ISRO is planning to go back to Moon again, and they're also planning to go back to Mars again, Mangalyaan too. So yes, there's a lot of development is going on in India and ISRO is doing a phenomenal job. So you all should look into that and help and join there and take it forward. So that is a great organization. It's one of the best organizations we have in India that is doing exceedingly well. A lot of talented people, a lot of new mission ideas, a lot of challenges they're overcoming. I have a lot of colleagues and friends who are working there. So yes, you should look into that, and ISRO is doing really, really great.
Yeah. So basically, sir, the question they meant to ask is that is NASA found Chandrayaan to lunar rover missing Chandrayaan? You know?
So actually, yes, there was a news item that you have seen that actually one of the satellites of NASA was had pictured in that missing things on that. That was for the lander that we found. So that information was transmitted to ISRO. And yes, that is a good relationship between NASA and ISRO. And we are jointly working together for a mission called NISAR. It's called NASA ISRO SAR, that synthetic aperture radar instrument that will be launched in future. So that will also help in disaster mitigation and get information about disaster areas and stuff. So yes, a lot of collaboration is going on between NASA and ISRO. So one thing I want to tell you to all of you that nowadays these missions are so expensive and so complex. So we'll have to all come together to work together. All these different organizations, the space organization has to come together and work together, and that's what is happening more and more. So that is, whatever we hear about all this, bad news in the press, and rightly there are a lot of bad news going on, but at the scientific level, there is a lot of good vibes and collaborative efforts among scientists, among the space agencies, so that we can all work together. And that is the key for future, that we'll have to all work together. Otherwise, it's too complex and too expensive.
Yeah, totally agree. So next question is from Mr. Avasti. So how is water chosen as a medium for finding aliens? Can't there be any aliens from existing without water?
So again, I actually already answered this question. First of all, that we have not found any aliens. Let's be very clear about that. We have not found any aliens. And then without water, that could be life, absolutely. But we'll have to find them. We cannot actively look for them, as I mentioned, because what do you look for? Right? If you are saying that, okay, that could be life of other kind, non-carbon based life that we know about, what do you search? So that is the question. So we cannot, if the process of searching for known kind of life that we know, you might find something that is other form of life, but you cannot really search for something that you have no idea about.
Yes, sir. So next question is from Dipti. That is there any space mission to mine the asteroids?
There is no, at least not from NASA. There is no missions planned to mine. Think about it. That we have a lot of people ask me this question. When we are going to. This is related in a way, that when we are going to go and live on Mars or live on Moon and all. So my answer to most of the time those questions are, why in the world we should go and live on Mars? We have a beautiful planet here. Think about this. The environment that we live in is beautiful, trees and all these water bodies and everything. And this is the perfect for human being to live here. So why should we go to Mars and live in an environment that is so harsh? Temperatures are so harsh. You'll have to wear all this protective gear to prevent because the atmosphere is much lighter, so that all these cosmic rays and everything, solar winds, they have stripped the atmosphere. As a result, Mars is not very a nice environment to live in. So let's protect our own planet so that we can live here happily. But again, we'll explore. Yes, there are some asteroid that you can mine and get some of the maybe rare earth materials and stuff like that. But you have to think about the costs involved and return in that. So sometimes it doesn't really make sense to mine in terms for economic sense. However, those exploring them, try to find out what they have, has scientific values.
Okay, so can you comment on the mining in Europa? On Europa?
Europa mining, we are not going to mine in Europa because first of all, this is a cold place. It's more of, as I said, I was covered with ice. What we are trying to do is actually find out if there are any organic materials or any form of life that is there underneath the water, underneath the surface, the water ocean. That's what we are doing. We are not going there to mine because we don't even know, if there is any mining materials are there, anything to mine. On top of that, how do you bring them back, even if you mine? It takes 7 years to go there.
Okay. Next question from Manisha. Species can be involved depending on the environmental condition. Like researchers have already shown the sign of life in different conditions. For example, in low temperatures, gravity variance. So why we didn't found any life on the exploring planets, for example, Mars?
Yes, we have found life in all planet Earth. Even if you go around and see, we get surprised all the time because initial our thought was that if there is a body of water, is a high density of a salt there, life cannot sustain. But we found a lake where very high salt concentration, but there is life existed there. So we are finding actually life in different kind of conditions, but so far we have not found life on planet Mars. So that is the question we are trying to answer, that did actually life ever existed there? We don't know the answer to that. Or, if the life exists today, that's what, and you have to think about that. We have not really searched too much. How many missions has been done? Have we actually gone and looked around all the places? No. So yes, there's a lot of potential, but you'll have to, from scientific point of view, since you have limited resources, you'll have to think that, okay, where can you go, and what are the things that we can analyze from here first before we actually go there. So I cannot answer that. Why didn't we find life on Mars? We are not trying to answer that question. We are trying to answer the question that did life existed ever? What are the evidence there? And also, can it be existing now?
Next question is from Shashwat. That can you comment on the crop circles formation?
I missed that. Repeat it.
How crop circles are made and what is its explanation?
Actually, you are kind of cutting off, keywords. I'm just missing. What circle? I'm not hearing it.
Crop circle.
Crop circle?
Yeah. Yeah.
So,
crop circle.
I don't know what you mean by crop circle, to be honest. I'm not able to understand the question.
You can skip this question. So, next question is from Joy Shil. What are the major challenges to send manned mission for the exploration of a potential habitable planet?
Okay, first of all, think about it. We have not gone to Mars yet. It takes 7 months to go to Mars. We have not gone because we have the technology to safely send someone to Mars, but we do not have the technology to bring that person back safely. So that is one of the challenges. So, but it's not that we cannot do that in future. However, we are not there yet. That is one thing. So we are finding these habitable planets that we have found. They're far, far off. As I said, thousands of years it will take to reach there. So going there and exploring them is beyond our capability at this point with current available technology. So if we in future, if we come up with some new technologies where we can travel much faster, and then there is a possibility maybe that we can look into that. But at this point, we actually don't have that capability.
Okay. Next question is from Mr. Firdaus. So, what type of opportunities, with respect to the chemical science engineers, they have in the space research?
So yeah, so let me answer if someone might have other questions also chemical science, someone is a physicist, someone is a mechanical engineer, someone is a civil engineer. So let me answer, in a very broad term, this question that, we need expertise in all different kinds of fields at NASA or any space program if you think about it. So we need chemists, we need chemical engineers, we need biologists. Astrobiology is a big thing for NASA. We need physicists, we need engineers, all different, stripes and shapes. We need electrical engineers, electronic engineers, civil engineers, mechanical engineers, thermal engineers. So physicists, of course. So we need people of all different expertise. So only requirement that you'll have to be good at it. Whatever, that's what I tell students, or whatever you are doing, pay attention to the basics. And then if you, are very good at it, so you have a good future, then you have the option of working in one of the space agencies.
Okay. So we take one last question from the chat box. That what is your opinion about the e-waste generation due to various missions, either by NASA or other space agencies? So how we are tackling it right now?
Say it again. What exactly the question?
E-waste generation by various space agencies, like either it is NASA or ISRO. So how we are tackling it right now?
Climate change you mentioned, or again, I'm missing the exact word that you are using for the big this
e-waste generation.
Again, I didn't hear it.
He's saying electronic waste.
Electronic waste. Electronic waste.
Yeah.
Okay. Sorry. Of course, electronic waste. As I'm saying, that electronic plays a big role in this, all this instrumentation, because you'll have to have communication. You'll have to have sensors. Many of them are electronic sensors, and all across the spectrum. When you talk about electronics, electronics can be of different spectrums, all the way from optical to microwaves, even RF, low frequency. So yes, electronics plays a big role in all these instrument development, as well as communications and sensor development and everything. So as I mentioned at the beginning itself, that we need expertise in all these different areas.
Okay. So there are a number of undergraduate students are also here. So can you please tell them that how they can start their journey if they want to do a space research or want to join NASA in their future? So how they can proceed?
Yeah, so as I said, there are NASA as well as other space agencies, they have internship programs. So you can look into that. You can go to the nasa.gov website or isro.in that website and can see what kind of opportunities. Generally, we have this internship website. They open up sometime in January. So, but again, I get a lot of email from a lot of people. Can I join as an intern? I cannot take you just like that. Because you have to go through this application process when it's open to everyone. So again, in January time, in January, it will open up so that you can apply. I don't know about the timeline for ISRO, so you should look into ISRO website and contact them and find out. So undergraduate students have this opportunity. Again, you can do some of the stuff yourself, form a small team, do some projects, try to do some projects, and then when you apply, then your resume looks much better, that you have already some experience in that area. So you should do that. And again, study the basics well. Again, I keep coming back to the same thing. So we try to take people who have studied the basics well. You understand the subject matter well. It's not just how many marks you got in your exam. That is not we are looking after. We are actually looking for your understanding of that subject matter. So pay attention to that. That will be my request to you all.
Okay. Sir, any questions from the dignitaries? Yeah.
Yes, please. You're mute. Sir, you're mute. So,
Director, sir, you are muted.
you are muted. So,
Okay.
Okay.
yes, now you are unmuted.
Audible now?
Yes, sir. Yes,
Yeah,
sir.
yeah, Dr. When you show that how to detect another solar system, you show two types of left hand and right hand somewhere. Just for my own clarification. So in the center was shown was the sun of that planet, that solar system, and outside was the planet.
So in the center was the star,
Yeah.
like our sun.
Yeah, the star. It appears the star itself is moving in a orbit. Is it that they also have a movement?
So, okay, so basically we know that our galaxy is also moving, so the star moves, but what I was showing actually kept the star fixed and the planet going around. But if you look at the entire system, we all know that they are also, we know this is expanding universe. As a result, not only the planets going around the star, even the stars themselves, they are actually moving. So it is very complex dynamics is going on in orbital dynamics.
So basically, but when we teach in the classes, they say star is fixed and only planets move around it.
But yeah, that is true, but star is not really fixed in terms of larger scale. You can, they're also moving.
Okay. Okay. Thank you.
Any other question from the dignitaries? Dr. Sudhana? Dr. Tarar? Okay. Anupma, are you there? Okay, I think she was trying to say, I would like to invite Dr. Sudhana for a vote of thanks.
So thank you, Dr. Gautam, for a wonderful exploratory lecture. I was about to raise a question, but that's okay, part of my Thanksgiving, that we still have the same question. Are we alone? So it's really mesmerizing to say that when I thought of this lecture, I thought, we are not alone. But it appears from your presentation, my understanding has changed, that we are alone and we are the best of the universe on this earth.
So to actually tell you that we are alone at the current evidence, but we are not really alone.
Yeah, individually we are not alone. Yeah, that's why this question has multiple dimensions. If we interact with NASA and like you, we come down to assume we are alone. We together are alone. But yes, my query in fact was, but that's again part of Thanksgiving, as I said. On one hand, we are asking that, whether there is a life on Mars or other planets. At the same time, there are fiction stories which we have to counter, which just say there are aliens, and then the scientists have to continue being a dark clearer and have a stand on the knowledge that they have gained. And I really thank you for putting us on a strong pedestal with one answer to this question. Of course, unless this has a dimension of, as you said, whether individually or collectively we are alone. So yes, we have the right way of question. And I also like when you said the life, the Earth being very, very, very minuscule, very, very small compared to other, planets on this universe and in this galaxy. And also even the sun. Dr. Sangwan asked whether the stars are planetary or not. So things are all relative. Wonderful, I was really mesmerized, and even the presentation, including the questions that came so interestingly. And I find Anupama keeping a bar on time limit and bringing this, this continuity by some other means. Maybe they will find you in your, chat box or mailbox or other ways of LinkedIn. that people will continue exploring, this universe, the world of NASA and world of space through you, because they could find somebody who has the closest of experience. So thank you very much for making this evening really, really wonderful, mesmerizing, and thought-provoking. And also, I would say, a lot of us have really changed their mindset by the exposure you brought in. So it's great, and I thank Director ACSR, Professor Sangwan, Coordinator Dr. Vinod Karar, and Anupama Rishabh, another team of these young research scholars who spare no time of the day on this earth, whether it is night for us and maybe morning for you, and for all the delegates who in large number gathered today to witness this lecture and make it a great day. So thank you very much, and thanks everyone who made it a wonderful event and a learning day. Thank you very much.
Thank you.
Thank you, everyone. Thank you, everyone, for joining us. Thank you, Dr. Gautam. Thank you, Dr. Susanna. Thank you, Director ACSI, for giving us time. Anupma, are you in the network zone now? Okay. So I think she lost connectivity.
Yeah, she has network issue.
Yeah. She's facing some network issues, sir. So
okay. So I want to end again. Thank you so much for organizing this. I had a great time. As I said at the beginning, I really love to talk to students, and from the questions you realize that students are very thoughtful. They're thinking about all these different questions that we are facing, and then how to overcome those. And so that's what it's all about. It's not that I give lecture and you all listen. I learn as much more and sometimes more than all the students themselves. So all of us are students and all of us are teachers at the same time. So we learn from each other. And I really again want to thank, apart from everyone else, Anupama and Rishabh, doing such a wonderful job. You are the future, and I'm so proud of what you have done. Thank you.
Okay, I would like to read a message from Anupama that on behalf of ACSR, SEC and IEEE AcSIR CSIO family, we present a vote of thanks to our dignitaries, Professor Sangwan, Dr. Gautam, Dr. Anjan Ray, Dr. Vinod Karar, Dr. Sadhana, ACSR families, and all attendees. Thank you for your presence here. Okay, so I will be ending the meeting. I'm sharing you the meeting YouTube link as well shortly, so you can share this meeting with your friends and family. They can have the exposure of what you have heard today. Thank you. Thank you, Dr.
Thank you. Thank you, everyone. Take care.
Bye. Thank you, sir. Thank you.
Bye-bye. Thank you.
Bye-bye.
Everyone.
Thank you. Great job.